Hello, good morning to all of you, and thank you, dear students and friends, for joining us at the Rajiv Gandhi Science Center. I am Bhamini Kamuyu, and I will be your host for today. Well, today is a very special day. It is the International Day for Women and Girls in Science. Well, the 11th February has been declared by the United Nations, as I just said, as the International Day for Women and Girls in Science. And why do we have such a day? This is because despite the global efforts that have been made to inspire and engage students and girls and women in science, women and girls still remain underrepresented in the scientific fields. And yet they continue to be underrepresented, as I just said. However, we need more equity and more diversity in science for the advancement of science. This year, the theme chosen by the United Nations is equity, diversity, and inclusion. Water unites us. So today we are going to talk about water, about science, and the science involved in water, which is very important for us. In this webinar, we will have 3 distinguished women scientists working in different sectors who are conducting scientific research in water, in the oceans, in hydrology, and wastewater. So it's a diverse kind of field. But before we start diving deep into the topic, let me introduce Dr. Jayanti Nuga, the chairperson of the Gandhi Science Center, who is a scientist as well, to address us. Dr. Nuga, please. Thank you.
Thank you, Bhavini. Director Dr. Molu of the Rajiv Gandhi Science Center, panel members, board members, heads of government and parastatal bodies, educators, and dear students. As chairperson of the Rajiv Gandhi Science Center, it is indeed a great pleasure for me to welcome you all to this important event in the context of the International Day for Women and Girls in Science. Good morning to you all, and a special welcome to our women scientists who are going to empower us and inspire all of us about how scientific literacy is a key element in the economic and social development of our society. As you are aware, science is not a popular subject among students, more particularly girls. Science and technology have improved the quality of our lives, and scientific and technological know-how is essential in all realms of our lives. Science has brought technology along with it, and our modern society is dependent on the inventions of science and technology. Science is everywhere, and it is going to equip us with various skills to deal with everyday problems and challenges. As you can see, this webinar is only possible because of science and technology, especially during this pandemic where we have been using the virtual platform. Incidentally, I would like to say that our minister would have wished to send a message, but she's not able to do so. And she has wished us all the best for this special day. Now, for a country like Mauritius to develop and achieve progress, we need not only a critical mass of scientists, technologists, engineers, doctors, and others in science-related occupations, but a scientifically literate population who will have the knowledge and skills to become more problem solving and have critical thinking abilities, and thus make informed decisions about various issues confronting them. Climate change, the COVID-19 pandemic, and many environmental and health issues have shown how citizenship skills to protect our health, the environment, food security, and other fundamental problems. Though enormous strides have been made at the global level, as Bamini has just said, awareness has been created since quite a long time. I remember I have been involved in all these campaigns and awareness projects since the 1980s when I was at the MIE, but still there is a very low uptake of science among girls. If you go to the website, you see that the GASAT, Gender, Science and Technology organizations, and many other women organizations have raised the alarm about that and tried to do something. But the problem still exists. It is a worldwide phenomenon. So in Mauritius, as you're all aware, statistics have shown that there is a very small percentage of girls who choose to study science at secondary level after the compulsory level. At the beginning, you have a lot of science people in science, primary level, but up to Form 3, year 3 in secondary schools, you see that the number of girls taking science do decline. And what you call it, it is like what you call a leaky pipeline. You have a lot at the top, and then eventually you see that very few scientists, women scientists, are you have a lot, sorry, at the bottom, and eventually you have fewer women scientists at the top. So research also has shown that boys and girls have equal abilities and talents. Both can do equally well, but for some reason, girls shy away from science. I've done a research on that when I was at the MIE, and that I have been in the classes, I have observed classes, I have interviewed teachers and students, and found out that there are various factors which are responsible for the low uptake. And as you all know, in this world, in a globalized world, a sound knowledge of science will enable our students, irrespective of gender, to cope with all the challenges if they go in a scientific career. And even if they don't go in a scientific career, science opened the doors to a lot of other possibilities, like you have the digital industry, entrepreneurship projects, and all that. So we just ask ourselves, what shapes young girls' decisions to reject science? Is it the instructional strategies, the pedagogy, the teachers, the parents, peers, curriculum materials, their lack of confidence, the culture, mathematics, and various other factors that are making them not to choose science? Research also has shown that many of these factors, to some extent, may influence them in their choice to study STEM subjects. And as you all know, more than half of our population consists of females, and they all have the potential to contribute positively if they are equipped with scientific and technological know-how. We do not have natural resources except our human capital. So we need the contribution of both girls and boys in the workforce. And I'm sure the girls, if they get involved, they are going to make a very positive contribution, because they may have a different ways of doing science, of practicing science, and even having an impact on their surrounding. We have what we call, as I said, the leaky pipeline. It leaks. We are getting fewer scientists at the top, not many in research also. And it looks as if there is a glass ceiling for promotion also, because many women don't make it to the top because of some discrimination or lack of opportunities. So, well, girls, I won't keep you long with that because our panelists are going to enlighten you more, but we have many role models who can inspire here. And I'm sure they're going to motivate you to have a deep thought about science and technology in our lives and make you engage more in science subjects and eventual career choice. Let us not be the missing half in the world of science and technology. Women have fought for the elimination of inequalities, diversity, and inclusiveness, and let us show that we can remove whatever barriers that exist and participate equally in our society and achieve economic and social progress. The future of our country depends on you girls and boys as well. So be involved at all levels, and eventually you'll also be involved at decision making. So when decisions are made, it will involve both girls and there will be less discrimination, we hope. We are thankful to the Rajiv Gandhi Science Center for popularizing science and technology. That's its mission. And also the ministry has always provided us its support in creating opportunities for the promotion of science among girls, women, and the population at large. Science clubs in schools are being set up, and this is one example where girls can get more fully involved. So I'm not going to keep you long. I wish you all the best and thank you for your attention.
Okay, thank you very much, Dr. Nuga. And as we have been talking about, the United Nations has declared the theme for this year as clean water. It's focused on SDG number 6, which is clean water and sanitation. Well, today we are going to learn about the work that is being done in Mauritius to ensure that there is clean water and sanitation in Mauritius. But also we are going to talk about the opportunities that the oceans as a water body is providing to us in terms of pharmaceuticals and biomaterials. So we will start with our first speaker, who is Mrs. Joysuri. She works at the Wastewater Management Authority, and she has a background in chemistry, and she has a lot of experience in terms of certification and accreditation. And she will be talking about the standards and requirements for the treatment and discharge of wastewater in Mauritius. So thank you very much. Mrs. Joysuri is actually with us at the center. Thank you for joining us. And
good morning, everybody. First of all, let me thank the Rajiv Gandhi Science Center for giving me the opportunity to present to you a highlight about the wastewater sector in Mauritius. So I'll talk about the WMA and how science has contributed in implementing or protecting the regulations that we have in place, put in place regarding the discharges and protecting our environment. So the Wastewater Management Authority, established in 2000, operates as an autonomous organization under the aegis of Ministry of Energy and Public Utilities, and is responsible for the collection, treatment, and disposal of wastewater. Well, being responsible for the wastewater sector in Mauritius, WMA manages the public wastewater system, which consists of 755 kilometers of sewer network, 673 pumping stations, and 10 wastewater treatment plants, which includes 4 main wastewater treatment plants that are located at Saint-Martin, Grand Bay, Beach-Tombeau, and Montagne-Jacou. As concerned for the 6 small treatment plants around the island, in the region of Flac, Villemette, Dubreuil, Bois-Manchon, Paille, and Rivière-du-Rempart. So WMA thus plays a vital role in the protection of the environment and in ensuring the country's sustainable development by the provision of appropriate water pollution standards, wastewater control systems, and management services to the entire population of Mauritius. So the vision for the organization of WMA is to protect our environment, public health, and vitality of our population, and to contribute to the social economic growth for a sustainable island. And the vision is to modernize the organization and protect public health and enhance the environment by collecting, treating, recycling wastewater for the social economic development of Mauritius. And specifically for this year, the objectives for year 2022, WMA is geared toward pursuing its efforts for projects to be implemented. for certain region. For this year, let's say, il y a non seulement la Malité Rouge, Route Bassin, la Soustrat Road, and environment as well as other projects at Residence Atli, connection Flat Rio at Pointe de Sable. So WMA will continue to modernize its infrastructure with a view to providing improved operations at all levels and capacity building, and also for capacity building of human resource. The overall objective is to strengthen both the technical and support services of the authority. Next. So when we are talking about the technical sides of the authority, wastewater laboratory is a section, is a department at the WMA, which represent the analytical arm. So what is its role and importance? Again, science, when we talk about laboratory, we can find out that science, how important it is in monitoring the quality of wastewater in view of checking compliance with various regulations and standards enforced as per the Environment Protection Act and also the WMA Act. And it also provides assistance upon request and approval to other departments, ministries, and organizations in Mauritius in investigating the suspected cases of pollution. So its core activities is for sampling. So a laboratory, if we are talking about collecting, treating, recycling wastewater, so obviously the laboratory have to do the sampling, testing, we have to report in a way that is comprehensive to the clients and also for environmental stakeholders, and maintaining accreditation, because whenever we are doing testing, we need to do it as per a certain level, procedure level that can be acceptable. So we are accredited to ISO 17025. So first of all, let's come to sampling. Okay, from where the wastewater collects samples. You can see here some photos that I have put here. You can see in the first photo, it is the wastewater treatment plant. Okay, so when we are collecting all these wastewater, so we have the sewer network, and then it goes to sewer line, and then it reaches the wastewater treatment. So there also science is important. How to process, how many load of pollution it is, what we have to do during the treatment, what type of chemicals we have to add. So it helps in, let's say, treating the wastewater that is coming. And also that we collect sample from wastewater treatment plants. The second one is from non-domestic premises, for example, the industries that are connected to the sewer network. And also to domestic premises where regions we have, or we already have the sewer network, so the house are connected. So for there also. Now we move to the section, next slide, for testing. The laboratory, obviously, it is equipped to test some 54 parameters. So these parameters that I have listed here, the pH, conductivity, TSS, COD, it's all about indicating the pollution load. So like a body, we have certain level of certain nutrients in our body. So here in the wastewater also, we need to check the level of pollutants that are present. So we are equipped, the WMA laboratory is equipped to test some 54 parameters. And we are actually accredited to only test for the certification for 24 out of these 54 parameters. And we do testing as per various regulations. So what are the regulation and standard? They are put in force as a regulatory system to ensure that whatever we are treating or we are disposing in the environment, whether they are compliant or not, is it safe? For example, to use for irrigation, is it safe, for example, okay, to discharge into underground? Is it safe to dispose in the surface water? Because we have an ecosystem in these water bodies. So you can see that we are equipped with sophisticated, there are equipment which needs science and technology also to operate, and at the level of to know the sensitivity of these equipment also, it's very important. You won't just test with simple kits. So we have sophisticated equipments which give more precise test results. So why is it important to test all this? Like I'm telling you that these water being recycled, being used for irrigation, for irrigating sugarcane fields, for irrigating golf course. So that is why we are equipped with sophisticated equipment so that it can give more reliable results. And we are accredited to ISO 17025, which is the requirements for the testing laboratory. So after this testing, so at the treatment plant, you can see the photo for methane field storage at Saint-Martin. This is the most sophisticated wastewater treatment plant in Mauritius. So what we are doing actually after treatment of these wastewater, it complies to certain standard. Then we use it we mix it with blended with other water, like for sugarcane fields, we blend it with other canal water and all. Then we use it for irrigation of sugarcane field only. And for some project, like in the region of Grand Bay, there are some IRS project whereby these water are being used for treating golf courses. Okay, and also if it is excess, it goes to CR4. So for every discharge, for every usage of recycle, there's a certain amount of load of pollution that we need to comply. Otherwise, we might not use it. Okay, next slide. So, so why it is important? So because untreated wastewater has a negative impact on our health and the ecosystem. So our environment, it is our heritage. So let's keep it safe and let's protect it together. Okay. So thank you.
Well, thank you very much, Mrs. Joysuri. I would kindly request you, if you have questions, please type in your questions in the question and answer box or in the chat box in the meantime. And our next speaker for today will be Mrs. Devisha Itusing. She is the Senior Hydrological Officer. So she's in the field of hydrology, and she will be explaining this to you about the work that she does in the hydrology section of the Water Resources Unit of the Ministry of Public Infrastructure. And she has a background in physics. And her work consists of groundwater licensing and authorization of private boreholes, exploitation and exploration of boreholes. And this is very important to ensure that there is a safe distribution of drinking water around Mauritius. So Mrs. Itusing, it's yours. Thank you for joining us.
So good morning, everyone, and happy International Day for Women and Girls in Science. So I'll be presenting on the management and development of water resources for Mauritius. So first of all, I'll speak about hydrology. What is hydrology? Hydrology is the science that deals with the occurrence, circulation, and distribution of water of the earth. And this can be explained via the hydrology cycle. So the hydrology cycle begins with the evaporation of water from the surface of the oceans, lakes, and reservoirs. The water vapor moves upwards and form clouds, which in turn condenses and fall back as rain. Now, when the rain falls on the Earth's surface, part of it flows as surface runoff in rivers and reservoirs, and part of it infiltrates into the ground and is stored as groundwater. Eventually, part of the surface runoff and the groundwater flows into the ocean, and the cycle continues. So we can see that hydrology is concerned with water in the streams, lakes, reservoirs, rainfall, and also water occurring below the ground surface, that is the groundwater. This is an approximate water balance for Mauritius. And Mauritius has an area of 1,865 kilometers square, and we receive an annual average rainfall of 2,000 millimeters, which is equivalent to an annual volume of water of 3,700 million cubic meters. Now, out of it, 30% is lost as evapotranspiration, 10% is stored as groundwater, and the rest over 60% goes as surface runoff. So in order to meet the water requirements to the different sectors in Mauritius for domestic, industrial, and agricultural use, both groundwater and surface water are used. So first of all, I go in the surface water resources in Mauritius. The island of Mauritius is divided into 25 major catchment areas, and the surface water system is served by 92 rivers and 232 rivulets, which originate in the center of the island and move towards the sea. And we have 7 major impounding reservoirs with a total capacity of 92.2 million cubic meters. So next, I'll move to the monitoring of surface water. This is an example of a gauging station to measure the flow of water in a river, and the main components of a weir, the recorder house, and a staff gauge. A weir is a measuring structure across the width of a river to allow us to measure the water level that is flowing in the river. And the staff gauge, as you can see, is just like a ruler. It is graduated in centimeters, and it provides an easy way of measurement of water level at a specific point in time in a river. In order to have a continuous permanent record of water level in a river, we make use of a continuous water level recorder, which is kept in the recorder house. And this allows us to measure the fluctuation over time in the river. And you can see that this is a hydrograph. It shows the water level fluctuation recorded over time. And the Water Resources Unit operates some 106 flow measuring stations around Mauritius, out of which 59 are equipped with a continuous water level recorders, and the remaining we have the staff gauges. Now, why is it important? First of all, it enables us to keep an up-to-date inventory of water resources in Mauritius, and this is used for all major work-related infrastructure works like construction of dams and reservoirs. Now, not all the rivers in Mauritius have a measuring structure. Then we make use of an apparatus which is known as the current meter to measure the velocity in the cross-section across the river. So it is helpful, especially during the dry season. We measure the velocity, and knowing the cross-sectional area, we can calculate the flow rate in the river. So next, I'll move to the groundwater resources in Mauritius. An aquifer. What is an aquifer? An aquifer is an underground layer which stores water, and Mauritius have 5 main aquifers, which accounts for most of the groundwater resources in Mauritius. First, we have the aquifer 1, 2, 3, 4, and 5. So, as already mentioned, the 5 aquifers account for most of the groundwater resources of Mauritius, and the groundwater can be extracted by drilling of a borehole. And the groundwater exploitation has started in the 1960s. Until now, some 2,028 boreholes have been drilled for different purposes. And presently, 605 boreholes are being used in Mauritius for the domestic, industrial, and agricultural purpose. And this map shows us the location of the borehole which are in use. The green circle represents the boreholes that is being used for agricultural purpose. The red triangle, it shows the industrial boreholes, and the blue circle shows the domestic boreholes that is being used to supply potable water to the population. So I'll move to the monitoring of groundwater. First of all, we would measure the piezometric level, that is the depth of water below ground level in boreholes using a sounding line. As you can see, this is the sounding line. It's just like a measuring tape. It is graduated in centimeters. And we have a sensor which is connected to the sounding line. So when the sensor is, we moves it down in the borehole, and when the sensor makes contact with water, a buzzer sound is heard, and we note the reading, the groundwater level depth. And we monitor around 240 boreholes island-wide for the groundwater level. And this graph, it shows the piezometric level in a borehole in Pudo, which is representative of a northern aquifer. The black line shows the average piezometric level, and the pink one shows the piezometric level for the year 2019, the blue one for 2020, and the orange one for 2021. And this small square is for the year 2022. And we can, if we compare it with the average piezometric level, we can observe that the water levels is presently above average for the northern aquifer. Apart from groundwater level, we also monitor the salinity. Salinity refers to the amount of dissolved salt that are present in water. And Mauritius being in an island, we are surrounded by the ocean. So we monitor the seawater intrusion in some 40 boreholes around the island. So the table below, it shows the volume of water used by the different sectors for 2020. So for this one, we have domestic, industrial, agricultural, hydropower. And if we look at the first row for domestic purposes, 51 million cubic meters comes from river runoff, and 103 from reservoirs, and 140 from groundwater. So we can see that out of the 294, 140 comes from groundwater, which is around 50% of the groundwater supply to the population comes from groundwater, and 30% from reservoirs, and 20% from rivers. So under the groundwater development program, additional boreholes are drilled to mobilize additional resources. And this table shows the list of 11 additional boreholes that have been drilled for the year 2010 to 2020 and commissioned, thereby increasing groundwater production by some 44,000 meter cube per day. And this one is the groundwater production monitoring. The table shows the groundwater production, that is the volume of water that is abstracted from boreholes to supply potable water to the population. And next one. This one is the daily monitoring of reservoirs. Reservoir levels are taken every day. The table shows the actual storage for the 7th and the 8th of February. And we can see that most of the reservoirs are about 90% of their capacity. And this one is a reservoir projections for management reservoir. And the data collected from the hydrometric network is used for planning and management of water resources. And the graph shows the storage projection for Mauvacoa reservoirs based on different scenarios, such as rainfall, the inflow and outflow from the reservoirs. And based on this, we try to see what will be the projected value of the reservoir by end of April 2022 to be able to manage our water resources. So next one is the groundwater protection. Normally, you need an authorization from the CWA to be able to drill a borehole, and subsequently, you will need a license to use water from the borehole, and the license has to be renewed every 3 years for agricultural purpose and 2 years for industrial purpose. So the hydrology section will process the application for the private drilling permits, for the renewal of license, for the increase of entitlement, and we investigate on the hydrogeological aspects and make technical recommendations to the CWA regarding the drilling and renewal of license. Also, regarding legislations pertaining to water issues, we have the Rivers and Canal Acts, Groundwater Act, and the Central Water Authority Act. And the institution responsible for the implementation of these regulations is the Central Water Authority, and the hydrology section provides the required technical assistance to the CWA. And the hydrology section gives its views on the applications for the water rights. The water rights to draw water from rivers and streams is governed by the Rivers and Canal Acts, and the hydrology section again provides the technical recommendations regarding legal issues associated with the water rights for increase of water entitlement, allocation, the change of purpose. And for the construction on water course, again, this is regulated by the Rivers and Canal Acts, and no construction of any kind in a watercourse is to be undertaken without the approval of the Supreme Court. And the hydrology section provides technical advice to the CWA on the adequacy of the structures. So the hydrology section also gives its views on the building and land use permit, EIA, PER, smart cities, and NHDC projects. So this was a brief on the responsibilities of the hydrology section for the management, development, and conservation of Mauritius. And I come to an end to my presentation. Thank you, everyone, and thank you, Rajiv Gandhi, for inviting us.
Well, thank you. Thank you very much, Mrs. Itu Singh. Actually, it was very interesting because every day it's like something which is automatic for us. In the morning, we just open the tap to have our drinking water and for domestic purposes, but we don't really think about all the processes that come behind this before we get the water at home. So moving from groundwater, now we are going to go into the oceans. As you all know, Mauritius has a vast exclusive economic zone, and there is numerous potentials for future exploration. So we are going to talk about a field called bioprospecting, and our resource person is Mrs. Prerna Roy, who is Associate Research Scientist from the Mauritius Oceanography Institute, and she works in the Chemical Oceanography Unit. And her background is a bit into biotechnology and molecular medicine, and yet she's working in the ocean research field. So you can see the different career opportunities that are open when you study science. And I will let Mrs. Roy talk to you about her research. So Mrs. Roy, the floor is yours. Thank you.
Okay, so good morning, everyone, and thank you for Rajiv Gandhi Science Center for inviting the MY to this webinar. Hello to our young audience and to all the panelists. So my name is Prerna Roy. I'm an Associate Research Scientist at the Mauritius Oceanography Institute, and I'm going to talk about bioprospecting of Mauritius waters. So just to start, I wanted to explain a bit what is bioprospecting. And sorry, that's not my first slide. This is my first slide. So bioprospecting seems like a complicated word, but it's basically human interaction with nature and how humans have been exploring and sustainably exploiting nature to better their living and improve civilization. And bioprospecting can be broken down, the word can be broken down into biodiversity prospecting. So it means like looking at the natural resources we have and seeing what we can use from those natural resources to improve human life. So throughout human history, humans have been using biomaterial to make clothes, to use as medicine, as cosmetics, and many other things. So the process of bioprospecting has changed a bit now in our modern times. All the resources that we get from nature are used for industrial purposes, and mostly in the fields of pharmaceuticals, of nanotechnology, cosmetics, aquaculture, agriculture, etc. So the process of bioprospecting is mainly collecting an organism from nature, understanding how it functions and its ability to help in a certain way in the process of human life. Then we isolate some specific components from this organism that can be used in the industrial process. We see in which process this can be used. For example, we can look at how it can help cure certain diseases, or it can improve production in food industry, for example, or in agriculture. And then we convert this raw material into a substance that can be commercialized. So from the first slide, I gave an example of a marine sponge. This is an animal from the sea that we extract some molecules which can be used as medicine, for example, against cancer. We test it against some laboratory model for cancer, and then it's converted into a useful form for human usage. So bioprospecting, as I said, is not a new process. It's been used for centuries for humans to be able to survive. In the past, it was mostly bioprospecting for plants and their ability, for example, to be used as medicine and cosmetic. This is cross cultures, for example, in traditional Asian medicine, Chinese medicine, Ayurvedic. And the process was basically taking mostly terrestrial organisms or plants and crushing them and getting a sort of gross form of biomaterial, and then using them in a form to be used as medicine or cosmetic. So I gave the example of turmeric, which is very popular right now, but has been used for centuries in India as antibiotic, as cosmetic beautifying agent. And then ginseng in more Asian culture, and which also has been used for the same purpose. The modern bioprospecting has evolved and has, so I won't say improved, but has, with the advent of new technology for observation, such as microscopy, we've been able not only to look at macroorganisms or big organisms like plants, like big animals, but also we have been able to look into small organisms like microbes, viruses, fungi, etc., to be able to see what they can bring as resources to humanity. The possibility of exploration also has improved. So before it was mostly terrestrial bioprospecting, but now we can go into other environments like the ocean, and not only coastal ocean, but the larger ocean, the deep seas, extreme environments. And with the advent of modern ships with submersibles, with remote technology to observe the sea, the ocean floor, with improved scuba diving, we've been able to explore different environments, which gave a possibility to look into other organisms which also live in extreme conditions, which produce natural products that have even more interesting properties. And genetics has also given another perspective to bioprospecting. So just for an example, before it used to be mostly crude substances that were extracted from plants and then used in their crude form. But now with the new technology, we can take an organism, extract the exact component which is helpful. So we extract a molecule, and use it specifically on a specific target in the human body to do a specific task. So, and also with the advent of genetics, we've been able not only to look at the possibility of using molecules, but also the genes of organisms to improve livelihood. For example, we've been talking a lot about the PCR with the COVID-19 pandemic, and we wouldn't have been able to do the PCR test if we hadn't been able to isolate a specific gene, a specific protein that enables us to do the process of PCR. So bioprospecting has been made very much more easier with the new technologies of genetics, of exploration of new technologies in the laboratories. So I'm just going to move on to marine bioprospecting. So it's exactly the same as terrestrial bioprospecting, except we're looking at the ocean. Why the ocean? It's 71% of the planet. It's 96% of living space. It's 80% of living organism, and it's 99% of the biosphere. So most of our living organisms are in the sea, but it hasn't been easy in the past to explore the sea because it's not our natural environment. But like I said, with the new advanced technology, now it's much more possible. We're still scratching the surface of what is in the ocean, but this is a really interesting field, and I hope it appeals to the young people, because it's like discovering a new world. It's like when Christopher Columbus discovered America. It's exactly the same. It's the unknown. So if you see on the left side of the slide, I've just shown a picture of how exploration is done in the ocean. So normally you go on a cruise ship which are equipped with all the equipment. You have those submersibles, which are, so submersibles are human operated. So you have people who go down in those submersibles. It takes about maybe sometimes 8 hours just to go down to depths of 6,000 meters. Oh, no, sorry, 600 meters. But it enables us to explore the bottom of the ocean. Those submersibles are equipped with robotic hands, with ways to sample things at the bottom of the ocean. You have also possibility of sending remote operated vehicles, which are just cameras to observe the bottom of the ocean and grab interesting organisms or substances. So, like I said, the marine environment is a very diverse environment. There are environments that we're more aware of, like the coral reefs, the mangrove ecosystem, just the coastal region. There are even more interesting, not more interesting, but more diverse environments such as hydrothermal vents. So I'm not sure if everyone is aware of that, but at the bottom of the ocean, you have small sort of volcanoes that are, some of are active, some are not active, but the active ones, they push out interesting minerals and metals. And so that's the second picture on the right. So you can see that around this small volcano, there are organisms growing, and these are really extreme environment, very high temperatures. Still, you have organisms living there, which is very interesting because humans can actually tap into those organisms, see how they survive in this kind of extreme environment, and use what they have as a biomaterial for humans to be able to use in extreme environments, etc. Then you have even the cold seas like the Arctic and the Antarctic, where you have organisms that survive at extreme low temperatures and produce interesting things that I'll show you later how they are being used. So I just wanted to, there are so many interesting things that have been discovered in the ocean, and I won't be able to make justice to everything, but I'll just show you some few things that I thought were interesting. So the first picture on the left is a jellyfish, which produces fluorescent protein called the green fluorescent protein. And this has been used for a long time in biology now. And the interesting thing about this is that this protein, which was extracted from this jellyfish actually lives in at very low depth in the sea. So it has to produce some form of light in order to be able to see where it's going around, because it's very dark at the bottom of the sea. But this protein also has enabled to advance science in a remarkable way. So this protein was extracted from those jellyfish, and it's been used in medical sciences, in other forms of sciences, to identify specific structures in the human cells. For example, I've worked with the GFP protein when I was at university. I was working on a project which looked at the neurodegeneration, and we wouldn't have been able to see those cells that were degenerating if we couldn't put something that sort of highlighted it. So what scientists did is that they put this protein, encroached it to certain structures of the degenerating cells so that it can be observed, and then the process of degeneration and regeneration can be observed. So the bottom slide shows some of the structures of the cell, such as the actin filaments. Maybe that's a bit too technical, so I'm not going to go into that. But basically, it helps to observe certain phenomenon that happens in the human body that wouldn't have been able to be observed if we didn't have a tag like a fluorescent protein to see them. The second picture is an algae, which is called Spirulina. And this has been used in Asian culture for a long time as a nutraceutical, that is a food additive, if you will. But now its benefits have been even more talked about, and it's been cultured and crushed into powders and added to food. It's very rich in many vitamins and good properties. So as you can see, it's good for allergies. It's lower blood pressure. It helps lower cholesterol. It's a very good source of protein as well. And then the next picture is it's called the ice fish. It's a fish that has been discovered in Antarctica, and it's a fish that, as opposed to other organisms that die in very low temperatures, it's able to survive in very low temperatures due to a protein that enables it to protect it against very cold temperatures. So this protein has been extracted, and now studies are being done to see how they can be used as a biomaterial. A lot of application is basically for the army, but it's also being used for research by NASA and things like that. So really interesting biomaterial from extreme environment from the sea. So the next slide, just briefly, just a map of the world and the different places. The change between the 90s and the 20s, not the 90s, I'm sorry, between 1999 and 2009, 10 years, where research in invertebrates from marine environments have produced really interesting molecules for medical purposes, genetics, for industrial purposes, for food, from the sea. So if you look at the graph, it just shows how many substances from the sea have been obtained, especially in the field of health. And this is the most prominent research being done in oceans right now in terms of bioprospecting. It's looking at organisms that can produce molecules that can be used against diseases, incurable diseases such as cancer, diabetes, Alzheimer's, etc. So the highest research is being done in pharmaceuticals, in health sciences. The table below just shows some of the medicine on the market now. For example, there's Yondelis, which is being used for cancer, and a few others used in cosmetics, in sunscreen, etc. So closer to home, so the Mauritius Oceanography Institute, which you can see on the top left, is found in Albon. The Mauritius Oceanography Institute was created to explore our extended economic zone. And as you can see, this is a map of our extended economic zone. So Mauritius, with its other islands, have an area of the ocean which belong to Mauritius, which is of 2.3 million kilometers square, plus the joint zone with Seychelles. So just briefly, the extended economic zone of Mauritius means that everything from the bottom of the sea to the water column, the resources, whether biological or non-biological, belong to Mauritius, and we have the possibility to export those resources. So it's been said in other presentations that Mauritius actually doesn't have much resources except for its human resource, but it has a big ocean resource, which would be good for Mauritius to exploit. So by prospecting of our Mauritius waters, it's basically exploring this huge zone, and most of it is deep sea. So Mauritius doesn't have a research vessel yet, but what has been done for 20 years now is collaboration with other countries which are more advanced in deep sea research. So this is just, we've collaborated a lot with the Japanese, and a lot of research, not a lot, but quite a few research have been done in our EEZ, especially on hydrothermal vents. So if you see on the map of the EEZ here, there are 2 hydrothermal vents. There are more than 2, but there are 2 mostly exploited in our EEZ. One is called Dodo and one is called Solitaire. So they were active some years back, and they had many interesting organisms growing around them. One of them was the scalyfoot. So you can see the small mollusk here. So the scalyfoot was known in other areas of the world, in other oceans, the black one, which basically is an organism which uses metals from being excreted from the earth for those hydrothermal vents to produce a scale that is really strong and that helps it to survive in extreme conditions, very warm conditions. But in the Mauritius hydrothermal vents, we found a related species, which is the white scalyfoot, which has only been found in our Mauritius waters. And this is really interesting because it uses other minerals to produce its scales, much stronger than the black scalyfoot, which has been found in other regions. And this is being studied by the Japanese now in collaboration with some scientists from Mauritius to produce biomaterial. So just as I said briefly, I'm just showing pictures of a cruise vessel. This is the Hakumaru. Me and my colleague have participated on this cruise, but many other girl scientists have participated in many cruises. One of the attendees is my colleague. She's gone on the first Mauritian-led cruise in the EEZ, the Nansen cruise, and she's been collecting water samples for various analyses. Many Mauritian women in science have been participating in those cruises, so that's really interesting. The second picture is a submersible. That's a Japanese submersible, and many colleagues from Mauritius have also gone down to very deep parts of the sea in this submersible. So that's really interesting, and there's possibilities for young if they're looking forward to doing studies in oceanography. The last one is a picture of me and the team with which I was working on this cruise. We've been collecting deep sea water samples to look at deep sea microorganisms and their biological properties. So closer to home now. Sorry, I'm running out of time.
Yes, please, can you just go quickly, and we will keep the time for questions.
Okay, so just quickly, the Mauritius Oceanography Institute mostly is involved in research in looking at biological organisms to look at medicine from the sea. So we work mostly with sponges or animals, but they're sessile animals that grow encrusted in different structures in the sea. And these organisms have been studied elsewhere in the world, but they produce molecules specific to their environment. So the ones found in Mauritius actually have specific molecules specific to our environment. And the studies being conducted at the Mauritius Oceanography have found that those organisms, those sponges, have properties, Alzheimer properties, anti-cancer properties, anti-diabetic properties, antioxidant properties. And we have really interesting results to show. There are also a few molecules. Sorry, I don't know if you can see this slide. There are molecules that have been isolated from those sponges, and which can now be which will be able to be commercialized to produce medicine against those diseases. There's another project that we're doing at the Mauritius Oceanography Institute related to macroalgae, so seaweed. And seaweed also, as you might know, have really interesting cosmetic properties, but they also use as food reagents. They have very interesting vitamin content, and some of them are very rich in calcium. And this is being studied for the ability for bone regeneration. So just to finish, this organism is the sea hare, which was collected years ago in 1972 by American researchers who've come to Mauritius. They picked up this organism from our ocean and developed this molecule, which is now a drug against cancer called Delasartine 10. And this is one of the most used drugs in the cancer field. Unfortunately, Mauritius never got any recognition for it, never got any royalties for it. And this is why it's important not only to do bioprospecting, but to protect our natural resources so that Mauritius can benefit from its research in the ocean. So thank you very much.
Yes, thank you very much, Mrs. Roy. Actually, it was very interesting. And I'm sure that the students are learning new things from the presentation and about the potentials that we have in our Mauritian waters. And it also shows why it is important for us to have, when we have the exclusive economic zone, what is it in there? Why do we need to protect, and why do we need to have ownership of that exclusive economic zone? So we have a question from one school, and the question is directed to Mrs. Joyce Wu, who, the question is about the sewer, it is about water pollution standards. So the question goes like this, that methane does more pollution than carbon dioxide. So what is being done at Saint-Martin for control of air pollution? And Mrs. Joyce will be answering that question for you.
So, yes, methane is important. At Saint-Martin, we have a design the treatment in such a capacity that the methane is mostly comes from the sludge. The sludge is digested. Okay, you'll see in one of my slides, I've shown the methane fuel biogas. So there, what happens, the methane is captured. Well, it is captured and it is converted or burned out to another form of carbon, that's a carbon dioxide. And in doing so, the process, we use this for generation of electricity, whereby the treatment plant there, the wastewater treatment at Saint-Martin, the electricity consumption, the energy that comes out from that burning, we use it to generate electricity, and it caters about 20% of that energy is being used by the Saint-Martin treatment plant itself to operate its activity there.
Okay, I hope this answers the question. And while we are here, I just want, I have a question for you. Can you just briefly explain what is wastewater? Like for the kids, like what is wastewater?
It's used water, let's say. The water that has been already processed, let's say from toilets, we have from industries, there are processes where we do dyeing, let's say for used water, it's used water. So from domestic and industrial also.
Okay,
Simply, yeah.
okay, so water that has already been used, and we can't just dump it exactly. Oh, actually, I have the same question has come from one of the students. So it is actually all the water that is used either in industry or for domestic purposes, and we just can't dump the water like this in rivers and in the ocean. They need to be treated, and through this treatment, it becomes wastewater treatment. So I have another question. What do you think Mauritius should do to limit pollution? So this is a very vague question. So let us say, what should we do to limit pollution in rivers and etc. In rivers and.
In fact, that's why the wastewater management is here. We have to connect to the sewer network. Okay? I'm also responding to the other question, how it is treated. So we have a sewer network. So all the houses are connected to that sewer line, and then it goes to the treatment plant. So we treat it, in fact, not to pollute the rivers, and also we must not discharge all the waste in the water courses. Okay, so we have to dispose it through a proper sewer network, or we have a septic tank.
Okay, good. Thank you. I hope this answers the question. And the next one, it will be directed to Mrs. Itu Singh from the hydrology section. And what are the future projects regarding? Okay, here it is. What are the future projects concerning water distributions in Mauritius? Is there anything like, we don't want to go into things which are not yet public, so we won't be asking delicate questions. So whatever you can answer on that, you're allowed to answer.
Actually, at the hydrology section, the water resources unit, we are mostly concerned with the mobilization of water resources and not about the distribution. So regarding additional water resources, as I have already mentioned, like we have a groundwater program where additional boreholes are drilled to mobilize additional water resources. And also we have, regarding of the surface water, we have the Rivière des Anguilles project, Rivière des Anguilles Dam, which is coming.
Okay, good, thank you. And you talked a lot about standards and ISO. Just in 1 or 2 lines, what is a certification and what is ISO for the students?
ISO, it's an international standards. Okay, ISO, so it's international standards. So there are specific standards related to environment. For testing, it is ISO 17025. So there is a lots of requirements. Let's say it will say, okay, you are doing your testing, how you are doing your testing. So all ISO is different, yes, okay, from each other. So for testing, it is ISO 17025. There we have requirements. How you do the testing, what are you doing during testing, what type of control you should be using, whether the personnel doing tests are competent. So there are several requirements regarding the management and also the technical sides.
Yes, so it's a kind of, you just can't decide yourself what is going to be your standards. There are certain established standards by different institutions in the world. And then we see whether we are meeting the standards. It's a kind of introducing a kind of rigor into your process, rigor and a well-defined process that is being followed. And this is important in science. And you do it at school during your practicals and in your science classes, of course. But then again, one more question directed to Mrs. Joysuri. I think she will be able to answer that. The waste from practicals at school. So how should we dispose of the waste from classroom practicals? Is it safe to just dump into the bin?
No, in fact, I know there is a project coming up. I think they have written it to Ministry of Environment. Would be better to answer. I'm not from Ministry of Environment, but I know there were schools who wrote to Ministry of Environment that they want to dispose, or they have to how to secure these waste. So I think not wastewater, but Ministry of Environment, we know what they have done here.
Okay, good, thank you. And if just please type in your question. In the meantime, I'm asking mine. So what is the bulk, Mrs. Itusing, like how much water are we using every day in Mauritius? Do you have an idea? Probably for domestic, do you have if you don't have, it's okay. Like how much?
No, I won't. This one will be directly like to SWA. We are responsible for the distribution of the water. So I won't be able to answer that, how much water. But the water being utilized, I have presented in the water utilization on a yearly basis, how much water is being utilized for different sectors.
In different sectors. Okay, good. And then probably I will ask you the other question. Can if tomorrow I want to exploit the water from a river or from a borehole, am I allowed to it? Like, is there any process involved?
Okay.
Do you need a regulatory
framework is a process? Okay, I'll speak first for the boreholes. For the boreholes, as already explained, the unit responsible is the Central Water Authority. So if a person wants to drill a borehole, he has to apply to the Central Water Authority a permit and authorization to be able to drill it. After the drilling has been carried out, the person cannot exploit the water. And again, he will have to apply for a first issue of license to be able to exploit the water. And this license is renewable on a 2-yearly basis for non-domestic purpose, and for agricultural purpose, it's for 3 years. Again, to be able to draw from water from a river, you will have to apply for a water rights at the Central Water Authority, and it's only the Supreme Court who can give this permission. So the first application has to be made to the Central Water Authority, and we will look after the hydrological aspect, and it would be like a court case that is going to happen with, and the Supreme Court is going to give the authorization.
Yes, so we can't just go and start exploring. There are,
Yes.
Yes, we can't. There is a process. It is a country, and the resources that we have here is the property of Mauritius, if we can say that. So we can see how science is merging with other kind of sectors, like the legal sector, standards, and other aspects. So do we have more questions? If please type in your questions quickly. We've got like 10 minutes left, and I will direct the next question to Mrs. Roy. Oh, okay. The question is directed to you, actually. Okay, so the question is about the sponge that you talk about, and its like its ability to cure Alzheimer or to treat Alzheimer disease. So do you think that in the near future it can turn into a medication?
So I'll just clear something out. When we say it's anti-Alzheimer, it's basically Alzheimer is a complex disease. So when we're looking at possibilities of curing the disease, we look at one process of this complex disease. So the molecules that we've found, they basically sort of annihilate one molecule in this Alzheimer disease that will reduce the effect of Alzheimer. Unfortunately, the process of taking a molecule that's been found into a drug is a very lengthy process because it has to go through clinical trials, which means it has to be tested on animal models and then on different human cohorts, so that to see whether it's toxic to humans, etc. Because it can have an effect in the lab, but if you put it in the human body, it can also be toxic, and instead of being a medicine, it can become a poison. So drug discovery can take 20 years, but we do have molecules, and now Mauritius is looking into partnership with other countries to develop the pharmacological products. So this is in the pipeline. I can't say more about it, but hopefully soon.
Yes, actually, it's a long process from the identification of the marine organisms deep down into the sea, and then extracting the molecules from the organisms, exploring the properties, and then identifying its potential. And then drug development is another aspect and another field actually itself. So these are the different kinds of interactions that happen between different scientists working in various fields. So if you have questions, please type in your question quickly. Otherwise, has there, Mrs. Roy, has there been any, are you aware if MOI or one of your colleagues from Mauritius has already identified molecules with anti-cancerous or properties or something like that?
As I said, at the Mauritius Oceanography Institute, we've identified many extracts and molecules with properties against cancer, Alzheimer, diabetes, etc. So we have the molecules. The question now is to convert it into a medicine. So the material is here. It's just a drug discovery process, but not only at the MOI, but the University of Mauritius also is working on certain organisms from the sea. So as I said, it's the commercialization part and the clinical trial part that has to be kicked in, has to come in. Yeah.
Yes, the commercialization part is another aspect, like it's another process as well. Well, if we don't have more questions, I will start by doing a quick round. Okay, we have got a last question, I think. Is anything being done about seaweeds in Mauritius, like Mauritius? There are things
Yes,
being
so
done, of course, but for Mauritius.
Yes, as I had to go quickly over this part at the end, but as I said, our unit is also working not only on sponges but on seaweed. It's a collaboration with the University of Mauritius and also CIROIS in Réunion, another research institute. So seaweed actually have very interesting properties. They have been mostly exploited in other countries for their cosmetic properties, but we're also looking at their medicinal properties. We have been doing tests now against cancer cells to see how they can be used as anti-cancer agents. They also have very high vitamin content. My colleagues have been exploring that aspect. We have a publication in the pipeline as well. And the seaweed also rich in certain minerals such as calcium. So the university and ourselves are looking into possibilities for bone regeneration with calcium obtained from seaweed. So there are quite a few research being done in that field in Mauritius.
Okay, good. So this is interesting here. So I will just do a quick round with our panelists. So do you have any kind of advice to give to our students, both boys and girls, of course, regarding career prospects or fields related to your field of work? I mean, in the hydrology section, like your colleagues, what are the different types of science backgrounds that they have? A quick summary.
So for the hydrology section, like to be hydrological officer, you have to have a degree in maths, either maths, physics, hydrology, or hydrogeology. And it's very interesting. Hydrogeology subject. So I just hope that we'll see more of girls coming in this field.
Okay, yes, thank you. And Mrs. Roy, I know about the Mauritius Oceanography Institute. So your colleagues, like what kind of training do they have? University studies or HSC studies, and what are the different departments that they work in?
I'm just going to say that, you know, science is a very, now science is very interdisciplinary. So in oceanography or marine sciences, you have people from not just any background, but very varied background. Just to talk about the units we have in MY, we have the physical oceanography unit, which mainly look at the physical aspect, like the currents and the different physical properties of the sea, the chemical oceanography, which is the unit I'm part of, which looks at the chemical properties of water, but also look at things like chemically produced molecules from organisms. You have the geophysical, which look at the tectonic plates more, or the sediment content of our waters, etc. But mainly what I want to say is that you do not have to have specific degrees in those fields. Like, I'm from a biotechnology background and I've done research in cancer, but I was able to contribute in some aspect of oceanography. And also, even if you have a mathematics degrees, or most of my colleagues are chemists, there's another who is a biologist and a biotechnologist. In the physical oceanography department, we have people who have studied ecology, people who have studied physics, mathematics, geophysics. You have people in different backgrounds as well. So oceanographic science is so broad that you can find a specific aspect of it that you can work in. There are people who have worked in mathematics, they have done mathematical modelings. This is really important for oceanography science because you need to have maps, you need to understand, projections, etc. So I won't say there's a specific science, but you probably have to do science to be able to work in oceanography. There is also aspects of engineering, of the equipment. Equipment is very important for studies in oceanography. So if you're interested in designing new equipment for deep sea research, for example, if you're someone who's interested in diving, we have professional divers at the NY. One of them is someone who's dove 100 meters scuba diving. So these are really important aspects as well. So it's not limited, and I hope that inspires the young to work in this field.
Yes, indeed, it sounds very interesting, and science is becoming more and more multidisciplinary. So, Mrs. Joycery, what about the Wastewater Management Authority? So, what are the work that your colleagues do?
Yeah, in fact, WMA is equipped more of technical personnel. Because since we are talking about collecting, treating, disposal, so we have in the technical cadre, we have a section whereby engineers are employed. We have a career, they can make a career there. So civil engineer, we have mechanical engineer, we have electrical engineer also, and also personnel in terms of technical officers who goes on site and all, they know chemical engineering. And for the lab also, there are lots of career you can. There are different type of jobs available, like the laboratory technicians. You have the scientific officers, the principal laboratory technicians, and then you have the senior scientific officer, and myself, the laboratory manager. So each job we have certain qualification, but mostly it's science. Okay, so we science and specialization, of course, for more responsibility, you need more science subject.
Okay. Yes, thank you very much. Actually, I am I'm very happy today because we have been listening to resource persons, collaborators from fields that probably previously we have not been talking, and it is great that Mrs. Idusing Mrs. Joysuri and Mrs. Roy, have accepted to share about their works from their work that they do every day and about the field, about their research with our students. And it is very important that students have this direct kind of interaction with scientists who are working in real life. So this is a little bit about the aim of today's activity. So to end, let me first thank all our panelists and their institution, Mauritius Oceanography Institute, the Wastewater Management Authority, and the Hydrology Division of the Ministry of Public Infrastructure. So thank you all very much, teachers and students. Thank you for joining us. I know that you have just started school, and we are very grateful that you've been able to join us on a positive note to celebrate this International Day for Women and Girls in Science. And on an end note, I would also extend my thanks to Dr. Nuga, the chairperson, our director, Dr. Molu, and my team, our team here at the Rajiv Gandhi Science Center, who have put up all the efforts behind. So thank you, and we hope that we are able to bring more such types of programs to you, and that you will participate actively with all the sanitary protocols. Despite the COVID, we still have to continue our work. So thank you very much, and until next time, see you. Bye.